So we're going to look at these two here first before we really delve into the lesson. Now, looking at these here, what do we need to do to be able to simplify this? We're going to times them, and we're going to use what property? Distributive property. So if I use the distributive property, we're going to multiply 4x with, and then 4x with, and negative 5 and x, and negative 5 and negative 3. And if we do this, well, 4x times x is 4x squared, because x times x would give us x squared. Now, 4x times negative 3, well, 4 times negative 3 would be negative 12x. Negative 5 times x would be, and negative 5 times negative 3 is plus 15. Now we can combine our like terms, the negative 12x and negative 5x, which would give us negative x plus and that's it. Now we can do the exact same thing with 4x minus 4 and x minus 4. We're using this distributive property. We're multiplying it out. So if we do this here, well, we'd have 4x times x, which would be 4x times negative 4 would be negative 16x. Negative 4 times x, negative 4x, and negative 4 times negative 4 is plus 16. And we combine our like terms, we'll get 4x squared minus 20x plus and we can multiply them together to get the answer. Any questions on this here? Now this here, we could go on and simplify it if we wanted to, and if we did this, well, it would be a times a is a squared. A times b is ab. B times a would be ba, or we can just say ab, because we can multiply any two things in any order. And b times b is, if we combine our like terms, we'll get a squared times 2ab plus b squared. We get this here. Now, what we're going to be doing with the rest of the lesson today, all of tomorrow and all of Friday, is going the opposite direction. We're not going to be multiplying two together to get the quadratic. We're going to start with the quadratic and factor it back out. So instead, we're going to start with this and end up back here. We have some steps. I have some steps that I've been given and I think work pretty well to help us get there. Previously, you factored polynomials of the form ax squared plus bx plus c, where a is equal to 1 to factor the polynomial of the form ax squared plus bx plus c. To factor it when a is different than 1, we first look for a GCF and then factor. Well, so whenever we look at this here, the first thing we need to look for is a greatest common factor. First thing we're looking for is a greatest common factor. Now looking at this here, and I will post these steps to Google Classroom for us. But the first main step is to find a greatest common factor. Now, once we find a greatest common factor, we're going to write two sets of parentheses with 3 spaces. is step 2. Step 3 is to find the sign of the middle term, because in both of them, all the ones that we've done so far, the first 3 that we did, in both sets of parentheses, we did have a sign, either plus or minus, and that's what we want to find. Now, the way we find it is we look at the constant term, or we look at the third term. If the third term is positive, the signs are the same, and they match the sign of the middle term. Now, if the third term is negative, the signs are opposite. Step 4 is going to be to find the factors of the first and third term. And lastly, step number 5 is going to be plug and check. And really, we're plugging and checking the whole way through, but that is what we'll be doing. Now, these steps really do work well if we do have a quadratic. If it is a quadratic, or that does work with some, actually, yeah, it would be a quadratic because we can use U substitution on degree 4 and degree 2. But mostly this works very well with quadratics. We'll have different methods for cubics and quartics and anything higher than that. But this here, when we have quadratics, this will work well. If it is factorable. So let's look at this here. Step number 1, find a greatest common factor. Is there a greatest common factor between 5x squared, 15x, and 10? 5. 5 will divide into all 3. 5 is a factor of all 3, so we can divide it out of all 3 terms. Well, 5x squared divided by 5 is x squared. 15x divided by 5 is exactly 3x, because 15 divided by 5 would be 3. And lastly, 10 divided by 5 is 2. So when we factor 5 out of 5x squared plus 15x plus 10, we get 5x, or 5 times x squared plus 3x plus 2. And we want to factor out the greatest common factor because it's going to make it a lot easier to be able to factor these. Now we can, a negative would also work because we could factor out a negative. I try to always keep the term, the constant term, not the constant term, the leading coefficient in front of x squared, the number in front of x squared, positive. It makes things work better. Okay, so did we finish step number 1? Okay, what's step number 2? So, 2 sets of parentheses with 3 spaces. Okay. Step number 2 done? Step number 3, find the sign. So we're looking at the third term. I sometimes will call it the constant term because a constant term is a number without a variable. But if we had, say, x squared plus 3xy plus 2y squared, it wouldn't technically be a constant term. But if we do have xy in the middle, x squared and y squared, this will still work It just wouldn't technically be considered the constant term. Now, the 2 is our third term. Is it positive or negative? Positive. So the signs are the same and they match the sign of the middle term. Now, there is some logic to this. Because when we look at these first 2 examples, the signs in the middle are the same, yes? And I get the constant term, the third term, by multiplying, so here, the negative 4 times negative 4. Well, negative times a negative is a positive. But when we did the middle terms, when we add them together, we get a negative, because the middle terms are added together, and the constant terms are being multiplied, yes? So what's the only 2 types of numbers that I can multiply together to get a positive? Is either a and a, or a negative and a negative. They have to be the same sign, yes? Okay. And for the middle terms, we're adding them together, yes? So if they're both negative, it's going to give me a negative, because a negative plus a negative is a negative. A positive plus a positive would be a positive. So really, when we're looking at this here, the only way that I can get positive 2 is if the signs in both parentheses are either both positive or both negative. So since it's positive and the middle sign is positive, it tells me that the signs in both of these parentheses have to both be positive. Well, if this had been negative 2, well, the only way I could multiply 2 numbers and it be negative is if one is positive and one is, or one is negative and one is, well, it really doesn't matter because that's the only way it works, yes? So it's just opposite signs. Okay, so are we finished with step 3? Step 4, find the factors of the first and third term. First and third. What are the factors of x squared?
1.
And?
2. No, 1.
1 times what?
5x.
So we would be looking at the 5x squared's factors if we hadn't factored out the 5. Because we factored out, we're really not concerned about this anymore. We're looking at this one here. So we're looking at x squared. What times itself, or what 2 things multiply together? Give me x squared. X and x. Now, 1 and x squared would work, but it wouldn't actually help us. Because if I say 1 and x squared, what are the factors of 2? 1 and 2, yes? Well, here I have 1 plus 1, which is times x squared plus 2. Well, 2 times x squared is, and 2 times 2 is, do I have this anymore? No. So unfortunately, x squared would not be considered a possible choice. So really, when we have this x squared, the only real possible combinations for x squared, only factors for x squared are going to be x and x. That's our only choices. Because the only things that multiply together to get x squared is and. Because we can't use 1 and x squared. We have to have an x in both spots. Now the factors of 2 are and 2. Because factors numbers that multiply together to give us our number. So factors of 2 would be 1 and 2. It's prime. There's only one set. Now whenever there's only one set of factors, just go on and throw them in. It doesn't really matter where we throw it in, because what is step number 5? Plug and check. So we're going to check to make sure we have it set up right. Now because we already factored out the 5, when I check this, I'm not going to get back to 5x squared plus 10x plus 2, because the 5 is on the outside. What we're going to back to check is our x squared plus 3x plus 2. Now we can do exactly what we did at the start of the lesson and multiply it all the way through, do x times 2, 1 times x, and 1 times 2. But what would x times x give me? Well, how did I get both of the x's? They are the factors of x squared, yes? So the reason I put the two x's there is because they multiply together to give me x squared. Well, wait, how did I get the 1 and 2? Well, those are the factors of 2. So do I really need to multiply everything back out? No, because I know these here and these here give me the x squared and the 2. Exactly. Well, where did we get the middle term? Well, the middle term came from the multiplication of x and 2 and 1 and x, because where those multiplied together is what gave us our middle term. Because the first and first, last and last give us the first and last. This gives us the middle. So if I'm wanting to check it, all I really need to do is our x times 2, which is, and our 1 times x, and 2x plus x is that the same as our middle term? So we factored it. Because we can multiply all the way through. I can do x times x, which would give me my x squared. The x times 2 and 1 times x would give me the 3x. And 1 times 2 would be plus 2. But the first and the last two, I know they should work out because that's how I got the numbers. We factored them to get there. And it's really the middle term that has the chance of changing and being different, depending on the setup. Now here, there's only one real way to set this up, because there's only one set of x and only one set of 2. Because x plus 2 times x plus 1 would be the exact same as this here. Any questions on this here? Let's look at another one. 4x squared plus 32x plus 60. There is a greatest common factor of 4. So we can factor it out. Because 4 divided by 4x squared would be x squared. And 60 divided by 4 would be, it would be 15. You had it right. That would be 15, because 15 and 15 is 30. 30 and 30 is 60. Exactly right. Any questions about step 1 with the greatest common factor? So we finished with step 1. Step 2. Write 2 sets of parentheses with 3 spaces. That finishes step 2. Step 3 is to find the sign. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, these signs are opposite. Our third term here is? And the middle term is? So they're both positive. Okay, that finishes that part. Find the factors of the first and third term. X and X. Okay, we can do 3 and 5. Because our factors of 15 are 1 and 15 or 3 and 5. So why would you say 3 and 5?
3 times 5.
Okay. So why would you pick it over 1 and 15? And let's check it just to make sure. So we can do x times 5, which is? And 3 times x is? Plus 3x is that the middle term we wanted? Because we got positive 8x as the middle term, and our middle term that we started with is positive 8x, well, after we factored out the 4. So this here is the correct factorization. And that's it. questions on these here? And again, we could have multiplied all the way up, but we do know x times x would give us x squared, and 3 times 5 is still 15. Any questions on any of this here? Okay, so our next one is 4x squared plus 13x plus 3. What is our greatest common factor? There's not a number that will go into 4, 13, and 3. Well, 13 and 3 are both prime. So we don't have a greatest common factor, so we can move on to step 2. 2 sets of parentheses with 3 spaces. Third term is positive and the middle term is positive, so our signs are both positive. So we need to look at the factors of the first and third term. Now the factors of 4 are 1 and 4 or 2 and 2. Now it also has an x squared, yes? What are the factors of x squared? And are there, well, we know for sure the first term should have x and, because 4x squared has x squared with it, so it's in the first spot. And there's only one set of factors for x squared. How about the factors of 3? There's only one set, so I'll just throw it in. Because there's only one way we can do it, so we put it in there, the same with x. Now the last thing we need to do is figure out, do we want to use 1 and 4 or 2 and 2? 2 and 2. And last but not least, we check it. 2x times 3 is positive 6x. 1 times 2x is plus, and 6x plus 2x is, and that is not correct because our middle term is not 8x, it's 13x. So we can remove the 2 and the 2, and we could flip it. So I could switch the two 2's. It'd be the exact same thing, yes, because I'm replacing a 2 with a 2. So flipping it doesn't work here. 4 and 1. Is, and that's exactly what we wanted, yes? Now with 4x and x, we could actually flip it, because if we tried this and we didn't get the right answer, because switching the 4 and 1 would actually change it, yes? Because it would be something different. So sometimes flipping them, just because it doesn't work in one order, we can always flip one of them and see if that works. I don't know why I'm erasing. Be ready for the next one. 3x squared minus 7x plus 2. Is there a greatest common factor? Okay. So we do have 3 sets of parentheses. 2 sets of parentheses with 3 spaces. Now finding the sign. Now the constant term is positive, so the signs are the same and they match the sign of the middle term, which is negative, as y'all said. So both of the signs are negative. Now we need to find the factors of the first and third term.
3 and 1.
X and x for sure. Since 3 is prime, we'll have 3 and 1. I just threw them. I didn't really decide. I just kind of 3x and x. I just put them in there. No real particular order. Just kind of put it wherever it fell. 1 and 2. Why would we pick 1 and 2, not 2 and 1?
I would probably go to.
Yeah. Does it really matter at this point? No, because we're going to check it eventually, yes? Well, 3x times negative 2 is negative 6x. Negative 1 times x is? And negative 6x minus x is? Is that what we wanted? And that's it. Questions on any of these here? Are you ready for the next one? I think we only have a few more after this. 2x squared plus 7x plus 6. Is there a greatest common factor? Well, 2 goes both into 2 and 6, yes? But is there a number that goes into all three? No. So we can start off with our 2 sets of parentheses with 3 spaces. And really the 3 spaces is just to give y'all some spacing idea, so you're not having things that are too small. Now, exactly, the constant term is positive, so the signs are the same, and they match the sign of the middle term, which is? So both of these would be positive. Now we need to find the factors of the first and third term. Well, 2x squared, well, the x would be x and x. The factors of 2 are there any others? No, so I'll just throw a 2 in the first spot. Now 6, because we do have 1 and 6, or 2 and 3. Which one do we want to try first? 2 and 3?
Yes.
There's a reason why this is not going to work, and I'll go on and check it and show you. 2x times 3 is 2 times x is plus, which doesn't match up. Now there's another reason for this. If we look at the first set of parentheses, we have what? 2x plus. Is there a greatest common factor there? Yeah, 2 and 2, yes? So if this was correct, it means I could actually factor that 2 out, giving us x plus 1 times x plus 3, yes? Well, wait a minute. If there's a greatest common factor in one of the parentheses, then it meant that there was a greatest common factor to begin with. Because when we dealt with the first ones, the greatest common factor stayed out front, yes? If I factored out of one of these here, it would be in the same place. That's kind of helpful, isn't it?
Yeah.
Because if there's not a greatest common factor here at the start, can there be one in either set of parentheses? No, because if I can't factor it out at the beginning, I can't factor it out in either one of the parentheses. So, okay. So if I look at this here, since I know that, since in either one of these sets of parentheses, I cannot have a greatest common factor, since there wasn't one to begin with, well, okay, we saw that 2 didn't work. What other number can I not put in with 2x? 6. So we could have 3 and 2 or 1 and 6, yes? There were 4 possible setups because I had the one we started with, yes? Or we could have had 6 and 1 or 1 and. That's 4 different ways I can put this, yes? But since we know that 2 and 3 doesn't work because of the greatest common factor of 2, 6 and 1 doesn't work because of the greatest common factor of 2. Did I just take 2 possible setups and throw them out? That's kind of helpful. And a lot of what we'll see, and you'll see with these here, is not that there is a hard rule that works every single time. That is like, okay, well, this is the rule, this is how it works. But most of the time, once we start doing enough of these, you'll start picking up on the patterns of how they work. and start solving them faster. Because most likely you won't see, okay, if there's not a greatest common factor to begin with, there won't be in one of the sets of parentheses in a textbook. But we do pick up on that pattern. Now if we check this here, well, 2 times 2x is 3 times x is plus, which gives us, is that what we wanted? And that's it. Any questions on this here? Are you ready for the next one? Four x squared minus 7x plus 3. Well, there is no greatest common factor. 2 sets of parentheses with 3 spaces. So we're saying negative, and since the constant term is positive, the signs are the same and they match the sign of the middle term, which is negative. So they're both negative. So we can say for certain that we'll have x and x, because that's the only factors of x squared. Factors of 3 are 1 and 3. Well, factors of 4 are 1 and 4 or 2 and 2. Which one do we want to try first? 2 and 2. Two x times negative 3 is 6x. Negative 1 times negative 2, or negative 1 times 2x is negative 2x, which gives us 8x. Okay. So we can switch the 2 and 2. Well, that wouldn't change anything, would it? Could I switch the 1 and 3?
Yeah.
Would it change anything? No, because it'd still be negative 1 times 2x and negative 3 times 2x. So neither one of those fixed anything. Now, 1 and 3 doesn't have any other factors, so we're going to have to switch 1 and 4. Do we want to put the 1 or 4 first? 1 and, because we can always check it, because if this works out, awesome. If it doesn't, we just switch the 1 and 4. Now, x times negative 3 is negative 1 times 4x is negative, which is that what we wanted? And that's it. So is there a real exact pattern to what we're doing? Not too much. We get it set up. Steps 1 through 3 are really just getting the setup. 4 and 5 is just plugging the numbers in and checking, plugging and checking. And one of the biggest things with this is the more that you do these, the more patterns you'll see, and the faster you'll be able to pick up which factors work. Are we ready for the next one? Two x squared minus 5x minus 7. So there is not a greatest common factor, which would be step 1. Step 2, write 2 sets of parentheses with 3 spaces. Our third step is to find the signs. Find the sign. So the third term is positive, the signs are the same, and they match the sign of the middle term. So they're opposite. So the signs are opposite. So one's going to be positive, one's going to be, which one's positive and which one's negative? It doesn't matter. Positive and negative, because all the way up to this point, we've just been throwing it in there, because again, the last step is to check it. So we found the signs. Now we need to find our factors. Well, exactly, because 2x squared, well, it should have x and. Now the factors of 2, 1 and 2. So we can say 2 and 1 or 1 and 2. I'm just going to throw a 2 down first. And we don't necessarily have to write the 1 in, because 1x or just x is the same thing. Factors of 7. And lastly, we would check. 2x times negative 7. Negative 14x. Plus 1x is that what we wanted? No. Yeah. I will normally switch the constant term, or the second term first, before I start changing the term with x. Now that's just dealer's choice, your own personal preference. Okay. Let's check this here. So 2x times negative 1 is? 7 times x is? And this gives us? Almost, because a negative, or 7 minus 2 is positive. Just 7, so is that what we wanted? Is it almost what we wanted? Because we got the correct number but wrong. So what's the easiest way to fix that? Switch the signs. Because I can make that plus and make this negative. Because if we ever come across the fact that, well, since we switched the signs here, I'll go on and finish this out. Well, this is positive and this is now negative, because 2 minus 7 would be negative 5. Now, if it worked out that the numbers are essentially the same, switching the 2x and x would work. But here, if I'd have switched the 2x and x, I'd have had 2x times negative, or 2x times 7, and then x times, it would give me, I think, positive 13 instead of negative 13. But in most of these cases here, if we get the correct number but wrong sign, you're better off just switching the sign than trying to change anything, because we have the right setup, just the wrong sign going with it. And that's it. Questions on this here? Last one. 3x squared minus 7x minus 6 is their greatest common factor. 2 sets of parentheses with 3 spaces. And exactly, since the constant term or the third term is negative, the signs are opposite, different. So we have a positive and a factors of the first and third term. Well, factors 3x and x. Well, we know 3 is prime, so 3 and 1. The only factors of x squared are x and x. Now the factors of 6. Am I restricted on how I can set this up? Can I put 3 and 3x together? Because 3 and 3x do have a common factor of 3. How about 6 and 3?
Yeah, so not 6 and 1.
Because we can't have 6 and 1. This doesn't work. But how about 1 and?
Yeah.
That would work. 2 and 3, but yeah, not 3 and 2. This one wouldn't work and this one wouldn't work, but we still do have 2 other ways that do work. One 6. Three x times 6 is, and it would be negative. And 1 times x is negative 17x. Is that what we wanted? Nope. Okay. Not 1 and 6. So 3 times negative 3 is negative. Plus 2x is that what we wanted? Yes. So this is it here. Now I will also say this. If that factor property or kind of rule, the fact that the greatest common factor to begin with, if there's not one there, there won't be in either one of the parentheses, is a little challenging to remember, that's fine. Because we can still plug it in, as we saw already when we did it with the 2x and 2 in the same spot. Did it give us the right answer? Well, no. And we can continue to do that. Now, if we did miss a greatest common factor to begin with, having a greatest common factor here will work. We just didn't pull it out. Does that make sense? It'll still work. We just didn't pull it out. Now, your assignment is on page 107, 3 through 10. This chapter here, I will caution y'all to not let the assignments pile up. Do not let them do that. Because this week we will have, because chapter 3.1 is 3 parts. There will be an assignment with each one of those. So there is at least 10 assignments in this chapter. So if you let these pile up, they will pile up fast. And most of the assignments, especially today's, are just factoring. Tomorrow we will be factoring. Fridays we will be factoring, doing this stuff here. So if you have time, go on and knock it out. And it'll help you remember and get the order of what we're doing down a little bit quicker. And the rest of this chapter is going to be involved with dealing with factoring and using it to solve quadratics. And we're going to find other ways to solve quadratics. That is